There we go. Cool. Can everyone see the PowerPoint? Cool, sweet. Let me know if anyone can't at any point. Cool. So tonight we're going to look at low voltage circuit switching. In the case of lighting types. So some of these are a little bit redundant in that a lot of the time we're going to use LED, but we still need to know about them because they still exist out there in the world, and sometimes they're used for specialized installations and specialized uses. So for certain, I think probably Andy might be able to talk to this a little bit. There are certain types of lights that they use for different effects and filming and photography to get certain effects and cast certain shadows. Yes, you can do it a little bit with LEDs, but some people still like to use good old incandescent bulbs. I once had a job where a tenant for a property had their light in the living room replaced with an LED, and then we got called in about 6 months later because no, I don't like that LED. I don't like the way it looks. It's making my head hurt. I want my good old incandescent light back. I want my batten holder back. So I had to go in and put in an Edison holder. A batten holder for her incandescent light. Yeah. And then you will still find a lot of these old bulbs in certain parts of certain towns where they use them for other things. So the basic principle of an incandescent light is it produces light by heating a tungsten filament until it glows. The problem with this is that as soon as we pass enough current for that tungsten filament to glow, if it's exposed to air, it will vaporize. So what we do is we fill that, we put a vacuum in that bulb, so that way there's no oxygen for the filament to burn and then therefore melt. So they usually emit a yellowish light with very good color rendering. So color rendering index 100. So that's why they're still used today. But they are highly inefficient. About 90 to 95% of the energy is lost as heat, not light. Has anyone tried to change one of these bulbs when they're still hot? Anyone else? Yeah, it hurts, eh? Yeah. You only make that mistake a couple of times. You know, I'm so used to LED. Even the LED bulbs these days still get a bit hot after they've been running for a while. But they usually don't have a great lifespan because that filament is getting so hot and the glass is getting so hot. Eventually there does get a little bit of air leakage into there. Very, very minute kind of microfractures in the glass. And so air will eventually get in there and the filament eventually just can't take it. And so around fuck that. 1,000 kilowatt. Was that HMI? Halide metal. I can't think what that means. Yep. Cool. So yeah, so they usually last about 750 to 2,000 hours, depending on the design and the usage. So the more often you run it, the hotter it'll get, the shorter the lifespan. Voltage sensitivity. So the brightness and lifespan are highly sensitive to voltage fluctuations, but they will still work on lowered voltages. So if you drop from 230 to say 180 volts at the house, these lights will still work. They'll be dim, but they will still work. That is one of their only advantages over LED. They will work when the voltage drops. So the brightness and lifespan are highly sensitive to voltage fluctuations, but they can still work. They've got no warm-up time. They provide instant light output when switched on. Environmental impact, so they do not contain hazardous materials like compact fluorescents, but they waste a lot of energy, and obviously to remake glass and tungsten filament, tungsten gets used for anything else. Cool. Does anyone any questions about incandescent light bulbs? Sorry if I sound a bit weird. There's a bit of sickness going through ECHO at the moment. We're down to 4 out of 6 tutors. Oh, cool. So as you can see from the diagram, they have a glass bulb, gas filling, or just a vacuum, tungsten filament, have support wires, lead wires, a Dumit wire, an exhaust tube, stem, fuse, and a cap. Cool. So what is the rule with Edison screw light fittings? There's one important rule when we wire up Edison screw light fittings that has to do with the way the pins are wired up. Polarity, yeah. L to the center pin, yeah. So the reason for this is as we screw it in, the threads on the outside could become live if we have the phasor neutral swapped. This means that someone could accidentally touch. I don't know about kill. You definitely give them a zap. Probably the only people who are using these still are old people, so maybe. I sound really bad when I say that. But yeah, always make sure you pay attention to the polarity of these of Edison screw light fittings. Bayonet cap does not matter because both the pins are inside and you push the light bulb and twist. Cool, fluorescent or low pressure mercury. Cool, so they use an electric discharge through low pressure mercury vapor to produce UV lights, which then excites a phosphor coating inside the tube to emit visible light. So it actually has to heat the phosphorus coating inside the tube to emit light. And sometimes what you have to do is when you turn it on at the test bench, you kind of have to stroke up the side. It's very fun to do with the pre-traders because you just kind of stroke up the side of the light fitting and give them a funny look as you're doing it. Yeah, you was gonna say you guys have met me and David. You know that we're a little bit screwed in the head. Cool. So it needs control gear. So it requires a few things like a ballast starter or an electronic ballast to ignite and regulate the current. So startup time. So the older magnetic types can flicker or delay before they turn on. The modern electronic versions are a lot quicker. Efficiency, so they're more efficient than incandescent lamps, typically to 50 or 100 lumens per watt. And probably next week we'll talk about what the efficacy of lighting, which is how many lumens per watt. So when we talk about efficacy, we're not talking about efficiency. So efficacy is a measure of how much light is output per watts, not how efficient the light fitting is. Yeah, when we talk about efficacy versus efficiency, it's a whole different efficacy only applies to light fittings. Cool. So the lifespan, so they commonly last between 7 to 15,000 hours, depending on switching frequency and ballast type. So they've got a range of color temperatures from warm to cool white. CRI usually between 70 to 85. And they contain mercury, so they contain a small amount of mercury, so they require proper disposal. And if you ever come across a fluorescent light fitting that has no coating, so they're completely clear, do not turn it on. Can anyone tell me why? Leak? Nope. Just have a guess. I want you guys, everyone, just put at least one guess. So basically, if there is no coating on the outside of the tube, so that coating is what gives it its color. It's basically absorbing those UV rays and allowing us to put out a different colored light. But if there's no coating to absorb the UV, it's putting out straight radiation, ultraviolet radiation. It will still produce some blinding white light, but it's also putting out a lot more UV radiation. So it can be a radiation hazard. I don't know if any of you are. So back when they made the original Star Wars movies, the reason you watch if anyone watched the newer ones versus the older ones, so the newer ones, the lightsabers move a lot faster than the older ones. The reason for this is because they were literally holding fluorescent light fittings. So inside the lightsaber handle, there was basically a power pack, and they were using that to have lightsaber battles. So they had to go really slow, otherwise they would break open the tube. And why is it bad if we break the tube? Mercury is bad, yes. There's mercury vapor and mercury gas. So yeah, that is very hazardous, especially if breathed in, which can lead to mercury poisoning if you do it enough. There were some guys whose job it was literally just to go around replacing fluorescent light tubes. So you can imagine if you've got, say, 30,000, 3,000 to 5,000 light fittings in a factory. It's a pretty big job going around changing these tubes. Obviously now we have LED high bays, but you will still find these out there in the world, which is why you can still pick up tubes from your wholesaler. Has anyone had any experience working on any of these type of fittings? Are you guys replacing, removing, swapping out tubes? Well, yeah, Daniel, you work on the fun stuff. Replacing for LED. Has anyone gutted one of them before? So they do make LED tubes. So they have so what you can do is you remove the ballast inside of the fitting, put in a driver, and you can put in LED tubes inside the fitting. So if they don't want to change them out because they won't match, you can say, well, we can swap out the ballast for a driver, and you won't notice the difference once all the lights are on. I think over at a church in Tawa, just because I knew them, used to go there, don't anymore. Over the span of the last 4 years, I've gutted and put back up about 58 or more of those fluoro fittings with new drivers and LED tubes, just because they didn't want to do them all at once. So basically, when they crap out, they call me in. I replace one or two at a time. Basically, charge them material. I don't charge them time because, fire and lightning and all that kind of stuff. Cool. So other gas discharge lamps. So you got several other different types of gas discharge lamps. So In all of them, light is produced by an electric arc passing through a gas or vapor, which excites atoms and causes them to emit light. So they've either got argon, neon, xenon, mercury vapor, sodium vapor, all depends on the type of lamp. They require control gear, so they're always going to require a ballast or starter to regulate that current and the initial arc. They always take time to warm up because that gas takes time to heat up. So they do have a better efficacy or efficiency than incandescent lamps. So more light, less heat, but they still get bloody hot. They always will have a longer lifespan depending on the type, but the color rendering varies wildly. So the fluorescents are moderate, 70 to 85, but low pressure sodium is very poor, monochromatic yellow, and metal halide is good at 85. Cool. So if nothing else, get this table down as notes, or that's if you're writing it out, or take a screenshot. If you use function print screen, and then you can just take a highlighting of it. But these are the types of gas discharge lamps you might come across. So other than the fluorescent, has anyone come across any of these? Metal halide, yeah. Compact metal halide, yeah. Yeah, big old floodlights, yeah. So a lot of the old hockey pitches, rugby parks, soccer, football fields is the correct terminology now. They have ceramic metal halide. Okay, my bad, Troy. I took a guess. I was wrong. Oh, yep. So yeah, there are LED alternatives, but a lot of the old ones still have these, and that's why they still make bulbs, is because they still have a use today. So I don't know if any of you know the history of Wellington, but there used to be a place up in Newtown called Athletic Park before they had the stadium. That's where they had all the big kind of rugby and football games, and they would have had these on the towers up there. Coincidentally, it is now a retirement village. If anyone is from around Wellington, it is where it sat on the site that's now a village at the park across from Wakefield Hospital. Yeah, so a couple of them, the halide and the high pressure sodium, use high pressure. So when you break them, they make a very good pop. But the rest are all and mercury pressure, high pressure mercury vapor. So those three, high pressure. So if you break the bulb, it makes a good solid pop. But yeah, three of them use mercury. Other is a mix of sodium and xenon or pure sodium. For the high pressure sodium, the warm orange yellow light. And then you've got low pressure sodium. So you'll find a lot of low pressure sodium and kind of roadways, security lighting. So, and like car parks, old car parks. Obviously, your metal halide are good for your sports arenas, your retail, and floodlighting. But as we say, a lot of stuff these days is getting replaced with LED, and they haven't given me the lesson plan for next week of what they want me to teach you. But I am feeling we'll be talking a little bit more about LEDs. So hopefully you got most of that down. If not, you can always watch the video. Cool. This is a low pressure sodium. One of these cars is red. Which one is it? All right, everyone put your guesses in. Nope, it is the one on the left. But you know, you wouldn't be able to tell in this light. It's obviously not very good for taking photographs, but it gives you enough light that you can see. Cool. So LEDs. So how it works, they produce light using a semiconductor diode. So going back to year one, what is a semiconductor? It could be silicon, or it could be something else. Yep, can be an insulator or conductor depending on doping. What's a more simplified sometimes conducts? Yep. Yeah, it has a lattice structure. Can conduct when meeting requirements. Yep, it's a good one. Cool. So a semiconductor is that it conducts some of the time under specific conditions, depending on the way we dope it and engineer it. And it either has so we have a p-n junction, so a positively and negatively. I use that term loosely. So positively doped semiconductor material will have an extra hole for an electron to fill, or holes for electrons to fill, and a negatively doped semiconductor will have extra electrons to fill those holes. So yeah, it uses the p-n junction to emit photons as light when an electric current passes through it, a process called electroluminescence. It's a very complicated word, basically electrical luminescence, giving off light. So it uses electricity to give off light. So it's very efficient, one of the most energy efficient lighting options, typically 80 to 150 lumens per watt, so good efficacy. So it provides instant light, so full brightness instantly with no warm up or flicker. Has anyone ever experienced an LED flickering before? Was it constantly? Was it strobing on, off, or was it a very quick kind of rapid flicker? Strobing? Okay, so what that means most likely is that the capacitor has blown. So if it's like going very slowly on, off, Usually that's because one of the capacitors has blown or a diode has blown and it's only getting half of the sine wave. Or if it's on a dimmer, it's the wrong type of dimmer. So when we talk about dimmers, we have leading and trailing edge. And what they do is they either cut off the front part or the back part of the sine wave. That's why we call it leading edge or trailing edge. It cuts off the leading or the trailing edge of the sine wave. It does this to change the basic frequency and dim the light. So either it's an issue with the driver, a connection issue, or if it's on a dimmer, it's the wrong type of dimmer. And also some LEDs are not dimmable. If you try and dim them, they just don't like it and say, nah, fuck you, I'm not turning on. So you always need to use the right kind of dimmer. How the drivers work. So the basic way the drivers work. Hold on. Right. We'll ignore that for a second. So make sure I can see your guys' chat so I can keep answering your questions. Cool. So the drivers. So the drivers, how they work. So you've got your phase and your neutral. So they come into your driver. Then you have, this is a transformer. You'll notice here the transformer is bigger on the left than the right. So it is what we call a step down transformer. So you will have 230 volts here, and then you might have 12 or maybe 24 volts depending on the driver. Now these are still AC. So then what we need to do is we then need to connect it in a way that we can change it from AC to DC. So can anyone tell me what a diode does? Yep, only allows current to flow in one direction. So for a diode. So this is what we call a full wave bridge rectifier. Then it's rating or it just breaks. Yep. So what we need to do is hook this up in a way that it will only allow current to, for it to be able to conduct in one direction. All right, guys, it has been a while since I've looked at one of these. And I've already made a mistake. Cool. So we connect sides of our transformer here. So now we can only get current coming out of this direction. I'm going to use a different color. Let's go with green. Out of this direction. And then the return path will be this way. Does that make sense to you guys? So far we've got incoming at 230, transformed or stepped down to 12 or 24 volts, and we're now using our rectification circle. So the way these diodes work is basically the triangle symbol means that if I have current flowing, let's use red, this direction, and it gets to here, I can't go this way because I'm blocked. So I have to go this way, and I can't go this way because I'm blocked here as well. But then if we have the other half of the AC waveform and we're coming this way, sorry guys, we're coming this way, down this leg, we come in here, I can't go this way, I'm blocked. I can go this way, and I can go that way, but I can't go this way because again, I'm blocked. So that's the way that these diodes work, is they basically, when we hit a solid line, we get blocks. When we hit a triangle, we can go through. So that's the way these work. Now, once we ignore the transformer side, we come over to here. Then we can draw the rest of our circuit. So we'll carry on with our green line. Comes down here. And eventually we will get to our LED. Yeah, so this is the symbol for an LED. And then we continue with our negative circuit back to here, the other side of our LED circuit. Now, on its own, do you think this will work? No. So why don't you think it will work? Needs voltage regulation, but what else does it need? Yeah, it at least needs a capacitor. So what we do is we connect capacitors like so. So the reason we use capacitors, and we'll because the capacitors seem like a short circuit, the current, we use purple for current, wants to rush ahead to these capacitors because it thinks it's a short circuit. It's actually to cause the inrush current, so that way, instead of being, so these are what the two waveforms will look like before and after we add the capacitors. So before the capacitor, we're going to get humpy or pulsating DC. What those capacitors are going to do, and this is our target voltage. If this is our target voltage, those capacitors, the more we add, it's going to end up being more like this. It smooths out the humps in our rectified DC. So we use it for smoothing. That's what we count it as. So we're smoothing out the DC waveform. So that's one other aspect of that we need to take into consideration for our LEDs. So an inverter kind of works the opposite. It basically uses what we call a switch mode power supply to constantly switch back and forth between the two. Basically, it switches the battery. So there's a lot more that goes into these. This is the kind of the more basic of what a inverter or a capacitor can do. So going back to our PowerPoint. So we talked a little bit about how the power supply for a driver works. We can get into it a little bit later on, or we probably will. So yeah, so instant light. So we talked about the or flicker in most cases. So it's got an extremely long lifespan. They're usually rated for between 15 to 50,000 hours, far longer than traditional lamps, which is why a lot of places they don't make the LEDs swappable. So a lot of fittings, the LED is hardwired or built into the fitting, because the idea is that by the time that LED fitting wears out and starts to die, it's going to be time to replace all of them, and they're outdated anyway. So I've had more LEDs fail to ant infestation, water ingress, and just being physically damaged than I have to actually failing since I've started doing electrical. So they're quite durable. They've got a solid state design, so they're resistant to vibration and mechanical shock. They put out very little heat, produce very little radiant heat. So most of the heat is conducted away and is at the driver. So if it's got a separate driver, the heat is usually at the driver, not at the actual LED light output itself. And it's got good light quality, good color rendering, and with a range of color temperatures available, and it can be made better through electronic circuitry. And doesn't have any toxic materials, so no mercury or hazardous gases. Now, has anyone heard of sunset dimming? Has anyone come across that term so far, sunset dimming? So C-bus controlled lighting, kind of. So sunset dimming is kind of newer technology that's come out. The best people to talk to about it are switch lighting. No, that's daylight harvesting. I'll talk about that in a second. So sunset switching dimming is when you dim it down. Instead of going from full brightness to dimmed, it goes from white light, the kind of the light you get in the kitchen, so the nice bright white, to a more warm, so almost orange or sunsetty, which is very good for kids' bedrooms because you can dim the light in the evening, and then they kind of start to think it's more like time to go to bed. It's better for when you're winding down in the evening. So when you're talking about when the sun comes down, that's what we call daylight harvesting. So daylight harvesting is where you have a IR sensor or a light sensor that senses how bright the incoming natural light is. And as the light dips, it turns the light on and increases the brightness of the light. It's used a lot in kind of like hospitals where they have either have natural light or the light comes on. Workshops, especially automotive workshops that have skylights. If it becomes overcast and hard to see, they will turn on and ramp up the high bays so that the mechanics still have good light to work on the cars. So yeah. Cool. So planning, simple lighting layout. So the things we need to take into consideration is the light fitting spread angle. So if you see there, a 15-degree light will only put out about 80 centimeters diameter for the beam on the light at a height of 2.6 meters. But once you go to 60 degrees, it puts out almost half a meter diameter. Sorry, over almost 5 meters diameter. So the angle of the LED matters a whole lot, especially if you're using recessed lighting. And the shape and use of the area. So is it a dining room? Is it a kitchen? Is it a living room? And then basic layout of the light fittings. Cool. So we will get to this. So lighting placement activity. So in the chat, hopefully it shows up. All right. There you go. So this is a Google Drive link. Save it as a bookmark. This is going to be the link where I drop all the files that are going to be for our use throughout the year. So if there's a handout required for the lesson or for homework or whatever, I will drop it into this folder and then you guys can access it. So can you let me know if you can or can't access it? And there should be a file, what is it? Probably gonna follow me. EE403.03 lighting layout activity. So it is a PDF. Yes, it is annoying. The best thing you can do is open the PDF, take a screen capture, and then open it in Paint. So I want you to mark out lights based on how many you think you need and where you think they need to be positioned. Cool. I want you guys to use the knowledge you have so far in the industry to just have a go. So the room is 6 meters by 8 meters. So if we go back to the previous page, so we'll go with the 60-degree angle. It is a living room. So we'll go with the 60-degree angle, and it is a living room. Or if you think the 36-degree or 24-degree are better, or you can use a mixture. Oh, hold on. So if you want to draw furniture in there to have a reference, so you've got 2 windows there. So this is kind of a closed in, so maybe it's more likely a bedroom. Cool. So the 2.4 meter ceiling. So switch location and entry points to ensure usability. The height of the ceiling. So high ceilings may require more powerful lights, but it's only 2.4 meters. And presence of natural light to reduce overlighting. So we'll go with that as a bedroom. So have a go at that while we keep going through the rest of the lesson, and we'll probably go through it as a group at the end. So there are some legal requirements that we've already gone over. So the Edison screw lamp holder. So outer screw contacts must be connected to neutral wire to minimize shock risk. This is actually in 3000. It is clause 4.5.1.2. Clearance from thermal insulation. So minimum side clearance between a non-IC recessed halogen lamp and insulation, 200 millimeters unless otherwise rated. So figure 4.7 in AS/NZS 3000. And roof space warnings. So where recessed luminaires are installed in the ceiling, a warning sign must be placed in the roof space near the access panel. Clause 4.5.2.3.2 and figure 4.8. So who knew this? Did any of you guys know that you're actually supposed to put a warning if there is recessed lights installed in the ceiling space? If there is access to that ceiling space, you are supposed to put a warning. How many of you guys think your bosses knew this? Fair enough, Connor. I think this has more to do with the old halogen and filament recessed lights, because a lot of the modern LED lights and drivers are allowed to be completely covered by insulation. So I think this has more to do with the older type of light fittings. I'm pretty sure that is the last slide. Yep. So we will go back to the lighting placement activity. So if we go back to our whiteboard, so as you can see over here, I have this already drawn up, ready to go. Would that include downlights? Well, a downlight is a recessed luminaire. Because basically recessed luminaire means a luminaire or light fitting that is recessed into the ceiling. So what I'm going to do is I'm going to leave you guys to do this for say the next 4 minutes. So I will be back at 6:40 and I will show you guys what I would do. But yeah, I will see you guys in 4 minutes. Okay, so has anyone struggled to be able to work on the handout that I gave? Okay, cool. So where would we put the light switch in this drawing? Yep, to the left of the door. So we put our light switch here. So. Because we have a window here and here, more than likely we're not going to put a bed anywhere near that. Now, assuming, okay, maybe it might be just a kid's room, the bed wouldn't be too big. I'm going to assume we're going to center it in the room. So about there. The bed is probably going to be maybe about I'm just assuming it's a single bed. So it's going to be like that. That's going to be our bed. Now, assuming this is a kid's room, what else might we find in a kid's room? Drawers, yep. So I'm going to say we're probably going to have a set of drawers. Maybe here. So, yep, drawers. Drawers, toys, Xbox, yep. Blanket on the floor with an iPad. That's all they need these days. Cool. And then what we might have is we might have a desk. We might have a desk next to the window so we get the nice natural light. A bookshelf. Yep. So we'll put that bookshelf. Move the image a little bit. Over here. So we'll put it from the corner, probably about, so BS for bookshelf. Yeah, and we might have say it's a nice house. We might have a TV on the wall here. Whoops. What's going on? Yeah, we might have a TV on the wall. You might have a TV on the wall there. Cool. So what does this mean for our lighting? Go back to the sparkly pen. Where do you think we're going to put the lights? We're going to focus on lighting up a few key areas. So if we're using the slightly smaller lights, so what I would normally do is I would tend to put lights one put lights in these locations. Now they would be smaller LEDs. I'm just using big circles so we can see them. So the reason I'm putting them in these locations, actually, now that I look a bit closer, no, I was right the first time. I don't know, when I first drew it, it looked a little bit wrong to me. Or because I drew them too big. Basically, you're trying to get them as evenly spread as possible. Even I'm getting myself confused now. Why do you think I'm putting them in these locations? Very straight down the middle? You could. I just think it's a bit too wide. Now, the reason I'm putting them in these locations is because I'm trying to illuminate mainly this area of the room. Because it's even, consistent lighting. Yeah. We want even, consistent lighting, and we don't want to waste too much time light washing down the walls. The other alternative to this, if you wanted to go with even smaller lights, is so that would give off even, consistent lighting and would light up the space in the room. It all depends on the angle of the light and how much light they're going to give off. And obviously, if we were to then put, so this is the kind of symbol for a dimmer switch. If we were to put a dimmer, then we could then control the amount of light in the room. So if we were to go back to that PowerPoint that we had before, so that 60-degree angle gives off about 5 meters, 500 centimeters. Yeah, that's 5 meters worth of light. So we probably wouldn't use that for a bedroom. We'd probably be looking at 36, which gives off 2.5 meters of light, or probably even less. But we're not looking to, but the more angle we use, the more light we're going to lose as we get to the edges of the light. And we'll look at this with the inverse square law a bit later on. But yeah, have a go at doing it. If you feel that you're happy with it, please email it to me so I can have a look. Just want to see where you guys are at. Everyone who sent me their plans for the other one, it was pretty much all of them were spot on and good. So I was happy with all of them. So I will stop sharing this now. Cool. So the best way to edit it is to take a photo screen of the, basically a print screen or screenshot while you have it open, and then open it in Microsoft Paint. That's the best way that I've found to do PDFs. But that's all of the teaching material that we have for tonight. So does anyone have any questions or anything they want to talk about, anything they want to bring up? Grab my computer. So no questions?